Okay, so today what we're going to do is we're going to talk about section 2.2. So here we go. Let me go ahead and set it up. Particularly on finding the characteristics of quadratics. So I'm going to pull up an example that I tried to get us started on today, and we'll finish it a little bit more tomorrow. But today I encouraged you guys, if you had a chance, to go ahead and graph on Desmos an equation. And ultimately, hopefully you were able to graph f of x, and we'll talk about it further tomorrow, is equal to 1/2 x squared minus 2, sorry, that should be x minus 2 squared minus 4. Okay, and so just by looking at this, I can see that there's going to be a translation of 2 to the right, down 4, and it's going to be shrunken a little bit by 1/2. Okay, a vertical shrink. So let me talk about this. This equation right here is something that we've kind of been working with. The parent graph is x squared, but it's in the form of a times x minus h plus k, which we've kind of alluded to before. This form of this equation is called a vertex form. Okay, and we know that it's going to yield a parabola. So the parabola has two different forms that we're looking at right now. The vertex form, which is what this is in, and also the standard form. Okay, so let me talk about these two kinds of forms. The vertex form, so I'm going to go ahead and write form here, is always in the form of y, or f of x, is equal to a times x minus h squared plus k. All right? The standard form is if you were to multiply everything out, and it looks kind of like a standard polynomial. It's f of x, or y, is equal to ax squared plus bx plus c. Okay, so let me talk about this for just a second. We can pick out characteristics of a quadratic just by looking at this vertex form. All right, if we had a parabola that was centered at 0, 0, and we shift it 2 to the right and down 4, we can pretty much pick out that the vertex, and let me just really quickly, in case people don't know what that is, and let me erase this. If we were to take a parabola and shift it 2 units to the right and down by 4 units, I know this is small to see, we'll end up getting a parabola here. I'm just doing a really quick sketch on the side. The vertex that started out at 0, 0 has now been shifted 2 to the right and down by 4. And so this vertex, which is what we call a min point, and later on if it's flipped upside down, is called a max point. That point's coordinates change from 0, 0 because it's shifted 2 to the right and down 4. The vertex is going to be at 2, negative 4. So the benefit of having something in the vertex form is that you literally can just pick off the information you need for a vertex. So if you were trying to look for the vertex, okay, you can pretty much just pull it out as h, k. Those will always be the coordinates of the vertex of a parabola if it's in vertex form. Okay. Now there's another vocabulary word that we're going to introduce, and you probably have been exposed to it already, is this idea of symmetry. If you were to fold a parabola in half along this line, it would pretty much lay on top of itself. So this axis of symmetry, okay, always goes through the vertex. Always. If you fold it where the vertex is, it's going to go through and be symmetrical. And so therefore, if you wanted to find the axis of symmetry, okay, the axis of symmetry is going to be at x is equal to, x is equal to h. Okay, so I'm going to stop here for a second. we have a choice of expanding this out. So we can use FOIL to multiply x minus 2 times x minus 2, multiply it by 1/2, then subtract out -4, which we've kind of been doing with even the example that we did today from 2.1 in class. But when we do that, we end up getting something called the standard form. Now the standard form always has coefficients. A is the coefficient in front of the x squared term, B is the coefficient in front of the x, and then C is the final number, or the third coefficient, if you will, if it's x to the 0 power. But anyway, the important thing I want to point out to you is that this A, B, and C comes from mathematical and algebraic computation of just simply expanding this. So if you're able to take out the vertex and the axis of symmetry from something in vertex form, these variables A, B, and C, which are dependent on this form, also can give you the vertex form. It may not be as clear as this, where you just pick it out, but after doing some calculations, we can find out by using A, B, and C, these coefficients, how to find the vertex and also how to find the axis of symmetry. And so we might be able to do this tomorrow in class, but just to give it to you so that you have a taste of how this looks like, to find the vertex of a polynomial or a parabola in standard form, you would only have to calculate using B and A, the x-coordinate for the vertex is -b/2a, okay? And then the y-coordinate is the function of -b/2a. So in other words, if you can find the x-coordinate, you just plug in the x-coordinate into the function, and that will give you the y-coordinate of the vertex. And of course, if you know what the x-coordinate is for the vertex, then you know that the axis of symmetry is going to be through that x-coordinate. Okay, and we'll actually we'll see if we have time to do that proof later in the class so that you can see where it comes from, and it doesn't feel like this random combination that I got from nowhere. It really does come from something that's legit. Okay, so on top of that, I want to talk a little bit about the detail of this parabola. As we graph more of these parabolas, you'll notice that, again, one of the things we've already noticed is that if, and I'll erase this down here, here's just some additional characteristics. Okay, so additional characteristics. Okay, you'll already notice that if this coefficient in the front, which is A, if it's greater than 0, then you know your parabola is going to open up. I'll just write then open up. And obviously, if the coefficient is less than 0, or if this is a negative value, it's basically reflected over the x-axis, then you're going to have a parabola that opens down. Okay, so that's one characteristic that we've kind of informally touched upon, but I'm just going to make a statement about it. Okay, and then we talked about this value of A as well. If the absolute value of A is greater than 1, then you have a situation where your graph is narrower. And if that absolute value is less than 1, then the graph is wider. All right. And then finally, something totally off to the side, and the book defines it, so I want to keep it consistent this way, is that a parabola, if it intersects the y-axis, the y-intercept, they call it 0, C. So if you see the letter C, they're talking about the y-intercept. It's not really something as commonly used as a linear intercept, like y equals mx plus b, but just as an FYI, if you do your homework on that and you run across that, it just means that it's the y-intercept, okay? So I'm going to stop here in terms of all the information giving to you, and I'm going to come back to this original example, okay? So I'm going to go ahead and erase this, and I'm just going to, for fun, and just because we should be critical about the math information that we receive, any information in that matter, okay, I'm going to go ahead and take this example and I'm going to expand it to standard form. So if I have f of x is equal to 1/2 x minus 2 squared minus 4, if I FOIL it out, I get x squared minus 4x plus 4 minus 4. Then I have to distribute the 1/2 through. I get 1/2 x squared, and this becomes minus 2x plus 2 minus 4, which equals 1/2 x squared minus 2x minus 2. So this is the standard form of this original equation. Okay? Now, if we wanted to find the vertex of this, let's go ahead and test the information that I just gave you. Okay? So I'm going to expand this. Okay? Let's say we wanted to find the vertex. Well, according to the information I gave you, the vertex is going to be negative b over 2a, comma, f of negative b over 2a. Okay? So in order to find that, in this case, I'm going to pull this off to the side. This is my a, this is the coefficient of my b, and negative 2 is my coefficient c, which I don't really need at this point. Okay? So I'm going to go ahead and just plug in the information that I have. So negative b is negative of negative 2, so that's going to be positive, okay, over 2 times a, all right, and a in this case is 1/2, all right, and then I have f of negative. I'm going to hold off on this, not fill it in yet until I get a number. So if I clean it up even further, I have 2 over 2 times 1/2, this is 1, so it's just going to be 2. Now if I plug in 2 into this equation, okay, if I have 2, and this is my x-coordinate right here, and I plug it into my equation right here, I'm kind of going about in a roundabout way. If I want to find what f of 2 is, it's going to be 1/2 times 2 squared minus 2 times 2 minus 2. And so this is 1/2 times 4, which is 2, minus 4 minus 2. So my f of 2 is negative 4. So my vertex matches what I originally got when I just picked it out. Remember, when I picked, oh, this is h and this is k, it's 2 comma negative 4. Well, I confirm it by doing this calculation. So you can, at least this is one example that kind of supports the table of information I gave you. And then obviously if the vertex is at 2 comma negative 4, then the axis of symmetry will go through that vertex, and I can go ahead and write the axis of symmetry will have the equation of x is equal to h, which is 2. Okay, so just using this one example, I can tell that the calculation to find the vertex does hold true.